Assalamualaikum and hi everyone. Let's continue with the last part for numerical computation and expression. In this topic, we will look at data conversions, complex arithmetic computation, and also the use of scanner to take input from the user. We'll start off with data conversion. Sometimes it is convenient to convert data from one type to another. For example, in a particular situation, we may want to treat an integer as a floating point value. These conversions do not change the type of a variable or the value that is stored in it. They only convert a value as part of a computation. For example, if we have int result, meaning that it should be an integer, but we have result equal to 4 times 5.12, which will result in decimal point 20.48. However, result is type int. If we try and run the code, this will give us an error. It cannot be compiled. If we convert 20.48, which is 4 times 5.12, to an integer, we can compile and run the code without any error. So, we can have result equal to int, meaning that we are forcing 4 times 5.12 to only take the whole number without the decimal point. But the result has lost the precision due to the conversion. By writing int, we are doing casting. We are going to look into casting in the next few slides. There are two types of data conversions. Widening conversions are safest because they tend to go from small data type to a larger one, such as from short to int. Narrowing conversions can lose information because they tend to go from a large data type to a smaller one, for example, int to short. Or in the previous example, we have seen going from double to int. In Java, data conversions can occur in three ways. The first one through assignment conversion, second is through promotion, and third through casting. Looking at the example from the previous slide, when we have result equal to int 4 times 5.12, what happened is we are doing narrowing conversion because 4 times 5.12 results in a double value. But as we are using casting here, where we write int in parentheses, we change the double value to int value. We are going to look more on this in the next few slides. This slide shows widening conversions, which is from small data type to a larger data type, for example, int to long, float or double, and narrowing conversions, which is from a larger data type to a smaller data type, for example, double to int, long or float. Widening or narrowing relates back to the values that each data type contains. For example, byte has the range of -128 to 127. Int has the range of approximately -2.14 billions to 2.14 billions. So, if we change from byte to int, we are widening it to be able to cover a larger range. But if we change from int to byte, we are basically narrowing the range from the ability to contain values up to 2.14 billions to a maximum of 127, because byte maximum value is 127. Assignment conversion occurs when a value of one type is assigned to a variable of another. For example, if we have int dollars equal to 20, double money equal to dollars. So, double money would have the value of 20 as well. Only widening conversions can happen via assignment. Note that the value or type of dollars did not change. What do you think the value of money is? Is it 20 or something else? Money is now 20.0 because it is of type double. Let's look at promotion. Promotion happens automatically when operators in expressions convert their operands or numbers. For example, if we have int count equal to 12, double sum equal to 490.27. When we do system.out.println and do sum divide by count, the value of count is converted to a floating point value to perform the division calculation. So basically, we have double sum divided by int count, so we will get the result in type double. The same goes if we have int divided by double, the result will be in double. Casting is the most powerful and dangerous technique for conversion. Both widening and narrowing conversions can be accomplished by explicitly casting a value. To cast, the type is put in parentheses in front of the value being converted. For example, if we have int count equal to 50, float result equal to float total divided by 6. So here we are casting the value total. So the result is 50.0 divided by 6, which is equal to 8.33. Without the cast, the fractional part of the answer would be lost. Let's try these several ways of writing our cast. Do you think all of this would produce the same value? The first one is what we have seen in the previous slide, where we have int total equal to 50 float result. And then we have result equal to float, so we are casting it total divided by 6. So as I said earlier, this becomes 50.0 divided by 6. So it will give us 8.33. Let's look at the second one, where we cast float and we also cast the value 6. So we have written result equal to float total divided by float 6. What happens here is it is basically result equal to 50.0 divided by 6.0. So it will display 8.33 as the result. If we see here, we know that when we do float divided by int, the result will be of type float. Here we have float divided by float. So this is redundant because when float divided by float, it will become float. The third one is we have result equal to total divided by float 6. So we are casting the value 6 as a float. This is similar to the first one, but the other way around. This means we are doing result equal to 50 divided by 6.0. So the output is 8.33. Last one, which is casting the value of total divided by 6 in parentheses. What this means is total divided by 6 will be evaluated first, as parentheses has the highest priority. So it basically is 50 divided by 6, which is 8. Then change it from integer value 8 to float value. So the final value of result is 8.0. It has lost the precision because we forced the division to be done as integers. Now let's look at complex arithmetic computation. I have mentioned several times before about maths class in Java. We have seen the API of it, where it listed all the methods that maths class has. Maths class contains methods such as square root and power. To compute x to the power of n, you can write maths.power x, n. However, to compute x to the power of 2, it is significantly more efficient simply to compute x times x. To take the square root of a number, we can use maths.square root, for example, maths.square root x. We can also use power method instead of square root. We can write it as maths.power x, 0.5. That is exactly the same as maths.square root. Let's look at this quadratic formula. So we have minus b plus square root b squared minus 4ac divided by 2a. This can be represented as minus b plus maths.square root b times b minus 4 times a times c divided by 2a. Keep note of the parentheses, where if you put the parentheses at the wrong part, then you will get different answer. Also, when you do multiplication, when you write the code in Java, you have to use the asterisk. For example, if you write 2a, when you try and compile it, it will give you an error. You have to write it as 2 times a. For this formula, it can also be written slightly different, such as instead of using b times b, we can use the power method. So we can write it as maths.power b, 2. Another option is instead of using square root, we can use maths.power, where we use it to the power of 0.5. That is exactly the same as maths.square root. All of this will give the same result, only slightly different ways of writing and the use of the maths methods. Other maths methods in Java, such as square root, power that we have seen before, they are also exponential, log, sine, cosine, tangent, finding the minimum and maximum values from two numbers, and many more methods. You can go through the Java API for the full list. This slide shows the precedence of the expression as we have learned in the previous part. So, even within the maths square root method, it will still use the precedence. For example, it will do b times b first, and then 4 times a times c, then only after that it will do the subtraction. So that is only within the maths.square root. Now let's look at interactive programs. Programs generally need input on which to operate. The scanner class provides convenient methods for reading input values of various types. A scanner object can be set up to read input from various sources, including the user typing values on the keyboard. Keyboard input is represented by the system.in object. What we have done so far is we declare our variable and then initialize it to some value. By using scanner class, we can take any input that the user type in from their keyboard. The following line creates a scanner object that reads from the keyboard. So we can write it as scanner scan equal to new scanner system.in. We can call our scanner object as any identifier that we want. For example, we can have it as scanner input equal to new scanner system.in. The new operator creates the scanner object. Once created, the scanner object can be used to invoke various input methods, such as answer equal to scan.nextLine, where nextLine is the method that takes in what the user typed from the keyboard. What data type do you think the variable answer is? If we check the API of nextLine within the scanner class, it states that the method will return a string value. So, variable answer should be of type string. The scanner class is part of the java.util class library and must be imported into a program to be used. How to import the library? Do you still remember from the previous topic? To import only the scanner class, we can write import java.util.scanner, or if you want to import the whole package of util, we can write import java.util.asterisk, where asterisk refers to everything within the java.util package. The nextLine method reads all of the input until the end of the line is found. That means if we have several words, all of those will be taken. Let's look at this example. We declared a string called name. Then, to take an input from the keyboard, we need to have scanner input equal to new scanner system.in. Note here that I call my scanner as input. And to use scanner, we need to have the import statement. So we have import java.util.scanner. In the next line, we have system.out.print enter your name. I use print method instead of print line because I want the user to enter their name on the same line as the sentence. If I use print line, the cursor will be on the next line. Since I expect the user to type in their name, whatever the user type will be assigned to the variable called name. And finally, when I want to see what has been entered, so we have system.out.println hello, and then reading the value in the name variable. If I run this code and enter my name, it will display hello Adila Nordin. Let's look at another example in this class called echo. Similar as before, we have scanner scan equal to new scanner system.in, as we expect to take the input from the keyboard, meaning that the user will type something. Then we have system.out.println enter a line of text and read the text entered using nextLine method and save the text into the variable called message. Finally, the message value is printed. What do you think we will see on the screen when we run this program? It will display on the first line, enter a line of text. Then, as we use println, the cursor will be on the next line. In previous example, we used print method because we wanted it to be on the same line. Say that the user entered "you want fries with that," the sentence will be kept in the message variable. So, when we print out the variable message, it will display "you entered you want fries with that." See here that we use the escape sequence /" to display the character double quote. Unless specified otherwise, white space is used to separate the elements called tokens of the input. White space includes space characters, tabs, and new line characters. The next method of the scanner class reads the next input token and return it as a string. What we have seen before was the nextLine method. NextLine does not separate the words by any white space, but instead it used the white space as part of the input. Let's look at the difference of next and nextLine methods to understand this better. This example is similar to our example before, where it asks the user to enter their name. The first one is by using nextLine, and the later one is using next method. What do you think the output of this program if I enter my name in both nextLine and next methods? For nextLine method, when I entered Adila Nordin, it takes the whole text as one value. That is why it printed out "Hello Adila Nordin." In the next method, even though I entered Adila Nordin, it finds the space between Adila and Nordin and separates it. It only keeps the first token or word before the space into the variable name, so it prints out "Hello Adila." I cannot access the word Nordin. Next method is useful. Say that if you only expect the user to enter one word, but they entered several words that you don't care about. So it will just take whatever in the first one or the input token and ignore the rest of it. However, even if you use nextLine method, but you only want to display the first word or first name, you can do it. This is slightly advanced than what we wanted to cover in this topic. But anyway, you can do it by writing system.out.println hello name.split, splitting it by space, and keeping it in the index 0. This is using the split method from the string class. What happened here is the value of my string name will be split when it finds a space. The word before the space is kept at index 0, and the next word after the space is at index 1. In any programming language, we always start with 0 as the first value. So, when I enter Adila space Nordin, at index 0 is the value Adila, and at index 1 is the value Nordin. This means if I have another println statement, I can have name.split space 1, where it will keep Nordin in index 1. It is really useful to refer to the Java API to know what other methods are available and can be used. Other than nextLine and next methods, we also have methods such as nextInt and nextDouble to read data of particular types. NextLine and next read a string, nextInt method reads an integer, and nextDouble method reads a double type. You can check the scanner class Java API where it listed all the methods, which include nextFloat, nextBoolean, nextByte, and many more. When you use specific methods, such as nextInt or nextDouble, you need to be careful of the value that the user might input. Let's look at this code. It asks the user to enter a number. It uses nextInt to read the value entered on the keyboard and keep it in the variable called first number. Over here, first number is also of type int. What do you think will happen if the user enter 1.23 instead of an integer? Runtime error would happen. This code can compile and run, but because of the wrong input, the program ends. It tells you the error, which is input mismatch, meaning that the program expects an integer, but the user entered a decimal point value. What do you think the output will be if instead of using nextInt, we use nextDouble and we enter the value 7? Is this one valid? See here that we have changed our first number to be of type double. When we enter 7, 7 will be changed into a double, so it will display 7.0. Let's look at another example of this class called guessMileage. It has the import statement for scanner and called scanner as scan. It has 3 variables, one of type int and 2 of type double, called int miles, double gallons, and mpg. It will display on the screen the sentence enter the number of miles and expect the user to enter an int value for miles because it used the nextInt method. Then we have enter the gallons of fuel used and it expects a value of type double as it uses nextDouble. It calculates the mpg, miles per gallon, by evaluating miles divided by gallons and display the value in the last print line statement. Let's look at this example input. The first one is an int, so entering 328 is valid. Next is a double, and mpg is calculated to have a double value. As we have seen before, double can have up to 16 significant digits. We can use system.out.printf and use the specifiers to adjust the number of significant digits to be displayed. For example, %.2f to display up to 2 decimal points. Say that we have string number equal to 123 in double quotes. Can we use this number to do any addition? To perform the addition, we need to change our string into an int, for example. This is where wrapper classes comes. So wrapper classes, it perform necessary type conversions such as converting a string object to a number. How can we convert string to int? Within the integer class, there's a method called parseInt that will pass the string to integer. So when we write integer.parseInt number, it changes our string 123 into a number of 123. So we can do addition with it. When we write integer.parseInt, where integer is in capital I, we are referring to the class that is called integer, spelled with the capital I. Other than parseInt, we can also parse it as a double. To do so, we will write double.parseDouble. Over here, we are calling the double class. That's why the D is in capital letter. The same goes if we want it to be a float number. Then we will write float.parseFloat. Take note that if the value that we have is not supported by the type of parse we are doing, it will give us an error. For example, if we do integer.parseInt 25.3, it will give us an error because integer.parseInt, it only expects an integer value. Also, it will still give us an error if we have characters other than numbers. For example, if we do double.parseDouble AB3. To summarize, we have learned about data conversion, where we have looked at assignment conversion, promotion, and also casting. Then we have seen some of the methods contained in the maths class. And finally, we learned about scanner object, how to write the import statement, and the use of reading methods such as nextLine, next, nextInt, and nextDouble. So that's the end of topic 3 on numerical computation and expression.